All right, first study guide problem here. This is called a logistic growth model. It has to do with this equation right here. We have this new species of fire-breathing chameleons that are called fire-breathing flans that have been discovered all along the Nepali coast of Hawaii. You better watch out. They give me this equation. P of t is the number that we have at any given time. I want a solution set, or so let's set of solution curves that shows above and below the carrying capacity. And then they give me this starting amount is going to be P of 0. And they want me to find P of t. So we'll start with part A here. The first thing I want to do is do dP dt equals, and I want to factor this thing out as much as possible. You can see there's a 6p for each of those. So I'm going to go 6 times p, open parentheses, close, and then fill in what's left. So I wind up getting 3 minus p. From there, what I'm going to do is recognize that p equals 3 is the value that makes that derivative equal to 0, along with p equals 0. So there would be a solution curve that goes like this along the t-axis. There's also going to be a solution curve that goes like this along the t-axis. I'm not going to get into the y in this particular question, but our other solution curves are going to go like that. And you should know that from the things that we've talked about. And they sort of asymptotically approach that carrying capacity. In this case, you can see the carrying capacity is 3. So I guess these new chameleons are super, super rare. All right, so let's see, that's part A. Now we're going to do part B. So I'm going to start with dP over dt equals 6p, open parentheses, 3 minus p. And I know p of 0 is equal to, what did we say up here? We start with 15 of them. So we have to do some separation of variables here. And this is a particular problem where there are many, many, many places where we can do things in an easier or more difficult way. So I'm going to try and take the easiest route whenever we can. So the first thing I'm going to do is dP. I'm going to separate my variables. I'm going to get p open parentheses 3 minus p with a 1 in the top. So I moved these two over. I'm going to leave the 6 there and multiply by the dt. So I get 6 dt. From there, I need to use cover up. So something over p plus something else over 3 minus p with a dp is equal to 6 dt. The right side does not change. So what I do here is I figure out what value I would, actually I'm going to do this one first because it makes more sense. But I'm going to figure out what value makes that box 0, what value of p. That value would be 3. And then I'm gonna cover this up with my hand and then plug in p equals 3 to the rest of the equation. Notice if I do that, I get p equals, or I get the fraction right here is 1 over 3. Same thing on this left side. I'm gonna plug in p equals 0 because that's what would make this 0. So I'm gonna cover up this piece and I'm gonna plug in 0. And again, look, I get 1/3. And that's pretty common with this type of problem. Okay, so next, I like to make this as simple as possible. Whenever I get fractions, I like to get rid of them. So we're going to multiply by 3 on both sides, and I'm going to get 1 over p plus 1 over 3 minus p is equal to, or sorry, dp, boink, boink, is equal to 18 dt. So from here, we're going to integrate. Integrate this side, integrate this side. The left side gives me an ln of the absolute value of p. And then for the next one, I get ln absolute value of 3 minus p. Now, there's a little bit of U sub or chain rule with this negative, so you have to put a negative there in order to account for this negative here. And then that's equal to 18t plus a constant. From there, I'm going to smash these two logs into a single log because that's going to help me to solve for p. So when I do that, I get ln, absolute value. I get a fraction bar. In the top, I get the one that has a positive piece, which is the p. And then at the bottom, I get the other piece that has the negative, and that's 3 minus p. If you forgot or missed this negative when you were doing your integration, then this is going to get pretty messy, and it's not going to give us the right solution. We wouldn't wind up getting that fraction. So the right side doesn't change, 18t plus c. Now what I can do is e to the both sides, because the opposite of an ln is an e to the. That isolates the fraction on the left side, p over, 3 minus p is equal to e to the 18t. And then I'm going to also say e to the c. So I'm using some rules that you should be familiar with. This is where the rule comes from. 2 cubed times 2 to the 5th. Well, there's 8 2's being multiplied. And this should say 2 to the 3 plus 5. So this multiplication is the same as this plus. And we can go the opposite direction. This plus is the same as that multiplication. So from here, I'm going to switch over to blue. I'm going to use my p of 0 is equal to 15. Typically, I think that this is the best spot to solve for your c value, or in this case, your e to the c with this one. So when I do that, I get 15 in the top over 3 minus 15 is equal to e to the, we end up getting 18 times 0, so that's 0, because the value is 0, times e to the c. This right here is 1, so really what I get is that e to the c is equal to 15 over 3 minus 15. So I get 15 over negative 12, which simplifies to both are divisible by 3. So we get a 5 over 4 that's negative. I was checking because I didn't remember that from my solution set, but that's correct. This is correct. We're doing it right there. All right, so what does that do? I'm going to then replace this right here with negative 5 over 4. So I get p over 3 minus p is equal to, and I'm going to put the negative 5 over 4 out front. I'll write negative 5 over 4 times e to the 18t. So from here, what I need to do is, I've got a bunch of fractions here. You should know the term cross multiply. Some people call it butterfly, but we can cross multiply here because our goal is to solve for p of t equals, right? And currently I have two p variables right here, and I can't easily solve for them, so I need to algebraically manipulate this thing. If I cross multiply, I'm going to do these times these like that. And that's going to give me 4p for the first one is equal to negative 5 e to the 18t, open parentheses, 3 minus p. So now I need to distribute this into both of these. That's going to give me 4p equals negative 15 e to the 18t, and then plus 5p e to the 18t. Now, usually I actually like to deal with this negative 18t here. Actually, yeah, sure, I'll do it, okay? I would much rather have exponential decay than exponential growth. So what I'm going to do from this line to the next line is multiply by e to the negative 18t. Because it's a lot easier to talk about something exponentially decaying because it goes to 0 than it is to talk about it exponentially growing, which means it would go to infinity. So I'm going to multiply by e to the negative 18t everywhere. That's going to give me 4p e to the negative 18t is equal to negative 15 plus 5p. So at this point, everything looks a lot more simple than it did up here, or even, when we were right here. So remember, our goal is to solve for p of t equals. So I need to move this thing over to the other side. That's going to give me 4p e to the negative 18t minus 5p is equal to negative 15. From here, what I'm going to do is write p, open parentheses, close, equals negative 15. and I'm going to fill in here what is left over. So what I mean by that, I said that poorly. What I'm going to do is fill in the parentheses what will make this line right here that I'm highlighting the same as this line right here. So I'm missing a 4 for my first term, and then I'm missing an e to the negative 18t, and then I have a minus 5. And I'm almost done here. One of the last steps is going to be to divide by the parentheses. If I divide, I'm not going to write it all out, by the parentheses, divide by the parentheses, it's going to cancel over here. So that's going to give me P equals negative 15 over 4e to the negative 18t minus 5. So let's talk about what this means. And actually, before I talk about what it means, I'm going to change the way it looks just a little bit. I'm going to multiply by negative 1 over negative 1. Why is that? Because I just really don't like this negative out front of the 15. I would much rather not have it there. So if I do that, I get that P of t is equal to positive 15. When I distribute this negative 1 into both terms here, and then put the positive one first, I get 5 minus 5 minus 4e to the negative 18t. So let's take a moment now to look at this equation and see why it makes sense. And I'm also going to give you a couple alternative ways to write this thing. So first off, if you remember from the top, we knew that P of 0 was equal to 15. If we go back up to the top again, we can also look at this graph and we say, oh, the carrying capacity was supposed to be 3. So we should get that the limit as t goes to infinity of P of t is equal to the carrying capacity, which is 3. So let's check that. When I plug in t equals 0, I get e to the 0, which makes this thing equal to 1. Then I get 5 minus 4, that's 1, and I get 15 over 1. And that gives me the P of 0 that we want. That makes sense. Let's check to see if the limit lines up with the carrying capacity that we got from above. All we got to do is plug in t equals infinity. And this goes back to my explanation before about having this e to the negative versus an e to the positive. If I try to plug in infinity or look at the limit as we go to infinity of this thing, that piece goes to 0. And it just gives me it gives me 15 divided by the 5, and that gives me 3. So it matches up with that. So it lines up with all that stuff. So this is the form of the answer that I like the most because it's easy to do the analysis that we just talked about. Another form you might get if you don't do this little step right here is P of t equals 15e to the 18t over 5e to the 18t minus 4. And this, we could do the same analysis of this thing to get these things like I just did verbally out loud, but it's just not as clean. It's a little bit more messy, and we have to think a little bit harder. So that's why I like the one that's in the box. In terms of getting the correct answer and like having the right answer on a test or something like that, I would take either one of these, but I do like that one better. So let's see if we've answered all the questions because we should always do that when we're taking a test. Did I sketch the solution curve? Blank carrying capacity? Yep, I did. 15. Tell how many there are. That's the PT. That's what we found in that box down there. Exists at any given time. What happens to the FBFs as time goes on? Well, I could use one or two things to answer that. I could either use this graph and say, well, the carrying capacity is clearly 3. We started at 15 up here, so it's going to come down to the carrying capacity. What happens? It's going to go to 3. Or I could use this limit work right here. So hopefully you feel good with that. And thanks for watching. See ya.